This is lab 3, part 5. We're going to be doing a similar experiment to part 1, except this time we switched the function generator to output AC. You can see right here that the function generator is set to 100 Hertz AC, and it is outputting a sine wave. The voltage is set to 1 volts peak, but I'm going to show you on the multimeter. When we measure with the multimeter, the measurement is in RMS, or root mean squared. And the RMS voltage is always approximately 0.707 or 1 over root 2 of the peak voltage, with the peak voltage being how high the sine wave peaks above 0. And one important quality of the RMS voltage is that it has equivalent power to what a DC voltage would have. And you can imagine that since this waveform is not at the same height all the time, it wouldn't transmit the peak power continuously, and that's why we have the RMS voltage. So I'm going to go ahead and measure across resistor 1, which is the 10 ohm resistor, and you can see that the reading is 0.163 volts RMS. And now measure across R2, which is the 33 ohm resistor, and the voltage is 0.540 volts RMS. Again, resistors 1 and 2 are in series. I'm going to increase the voltage now to 2 volts RMS. I'm sorry, 2 volts peak on the signal generator, which is the equivalent of 1.411 volts RMS total. Measuring across R1 only, the voltage is 0.327 volts RMS, and across R2, the voltage is 1.083 volts RMS. I'm going to increase the signal generator output to 4 volts peak, which is equivalent to 2.824 volts RMS measured on the multimeter. Measuring only across R1, we have a voltage of 0.655 volts RMS, and across R2, a voltage of 2.167 volts RMS. Now I'm going to turn the voltage back down to 1 volt peak, like we started with, and you can see it's back to 0.704 on the multimeter. And I'm going to increase the frequency from 100 Hertz to 500 Hertz. And you can now see the output frequency is 500 Hertz. So we're going to attempt to see whether this had any change on the measured voltages. And the measured RMS voltage on the multimeter is 0.704. The voltage across R1 is 0.163. And the voltage across R2 is 0.540. I'm going to increase the voltage to 2 volts peak, which is again the equivalent of 1.411 volts RMS measured on the multimeter. Across R1, we have 0.327 volts RMS. And across R2, we have 1.083 volts RMS. I'm going to increase the voltage again to 4 volts peak. And we have a total measurement of 2.824 volts RMS across both resistors. Measuring across R1 only, we have 0.655 volts RMS. And across R2, we have 2.167 volts RMS.